Hello guys, today I'm going to assemble version 2 of my RC controller, and yes, all these parts are part of the controller, so better get started. Before you start soldering, make sure you have your sponge on your soldering iron so that you can clean the tip of your soldering iron. Make sure you keep it clean, and when you're ready to start soldering, make sure and put a little dab of solder on the tip of your solder, not a big blob, just a little dab, and it'll make the soldering the components a little bit easier. If you put a big blob of solder on the end of the soldering iron, it will probably end up getting full of dirt, and it'll either not stick properly, or worse, when you go to solder to the pad, the whole blob will just flow onto the pad and it'll be really messy. So you don't want to put too much solder into onto any of the pads. You just want to put enough. There's no point wasting the solder, and if it's messy you can get other problems, especially if you need to take a part out. It can take forever. And if you really want to learn how to solder properly, you should look up Dave Jones and the EEV blog. He has a YouTube playlist of videos about all kinds of soldering, SMD and through hole, everything you could need. Okay, when doing this kind of thing, I always like to start from the lowest components and work my way up. So the first thing, the lowest component is obviously going to be the SMD regulators. So let's get our 3.3 volt regulator. That's going to go in there. So the easiest way to do this is to not do it in front of a camera, but if you can't avoid doing it in front of a camera, the easiest way to do it is to solder one of the pads. So now we have that pad ready. Then get your component, solder the same leg on the component if you can. Okay, now it should be easy to solder in. It's a little bit difficult for me to see because of all the lights. Okay, I'm going to have to lift it up to see if that actually soldered or not. Okay, that seems alright. I just straightened it up a little off camera. Let me see, can I sort out these lights? I can barely see what I'm doing here at all. Okay, it might be easier for me to solder using the camera, weirdly enough. So let's see if we can do the next one. Be very careful if you're soldering any component and you have your finger on it, because the component could be designed to distribute heat out through the case. So you could solder a pin and then it could get very hot very quickly and burn your finger. So just be very careful with what way you hold things. It's always better to hold things with tweezers. We'll do the same thing for the next regulator. Solder up one of the pins. Put a dab of solder on the pin of the component. And now align them and solder it in place. Okay, so that's that in. I'll just straighten it up off camera here again. So that's the first thing done, the two SMD regulators. It's obviously not too difficult. I have very shaky hands and I managed it, so it should be no problem to any of you guys to do that yourself. And that is probably the hardest part of the thing. So next I'll just move on to the diodes, I think. So with the diodes, we can see the marking here. You can see there's a dark grey line there, and that indicates the direction that you need to put it in. So you need to mark this line up with that line. If you want to be extra sure, you can see here's the positive from the battery, and you need that to flow through the diode down to the power switch here. So your diode has to go in like that, and the same over here, the positive coming from the DC jack. You know, these other two are the DC because they're not connected here. Flip it over, you can see there's the connections through to the ground plane. So these two are clearly the ground, and the top one is the positive, and that comes down through the diode, so you know you have to have it in that orientation. So you just put your diodes through the hole, double check your polarity, so the white line is in the right place. Then you can just solder those pins. Make sure you hold the soldering iron to the pad long enough for the solder to flow properly. So the end result should look like a nice smooth sort of like a bubble, I guess. It shouldn't be kind of jaggedy or rough looking, because that might suggest that you didn't hold it long enough. But you'll see once the solder starts to flow, it'll be clear that it's turned to liquid and that it's hot enough. Once you have your components soldered in, just snip the legs off as tidy as you can. These little bits that you cut off, you might want to just store them in a jar or a little tin or something, because they can be useful for making little jumpers on when you're making up a circuit on a breadboard or something like that. So next I'm going to add the resistors. The first two resistors we have here, they create a voltage divider, and basically what that does is takes the voltage that we're supplying into the board and splits it down to a level that the Arduino can read. So say we put 12 volts in here in the DC jack, we can't put that directly into an Arduino pin, we have to take it down under 5 volts. So we use this voltage divider. So R1 is a 3K3 resistor, or that's what I'm using. You can use something different if you want. And R2 is going to be a 1K resistor. So I'm going to use through hole resistors, but you can see they don't just have holes, these resistors, they also have pads, and that's so that if you want to use SMD resistors to practice your SMD soldering, you can do that. But I'm just going to use the through hole components for now. I just wanted to set the board up so that you had the option if you wanted to practice those kind of things. So the next resistor is the 1K ohm on the base of the transistor, which just limits the current. Make sure we don't damage the Arduino output pin. For those of you who don't know, resistors aren't polarity sensitive like the diodes were, so you can put the resistor in whatever orientation you want. The next two up here under the XB are on the RX and TX lines of the XB, and the purpose of them is to isolate the Arduino from the XB when you want to upload your sketch. So these two resistors allow the signal from the USB cable, which has the sketch that you're trying to upload, that allows that signal to override the connection with the XB so that it doesn't interfere with the upload process, or that's the idea anyway. The last pair of resistors are here at the top. We have one here and one over here, and these are meant for the infrared LEDs that should go on the top of the controller. I haven't got the infrared LEDs yet, so I'll have to test that out later on. So that's all the resistors in place. R1, the 3K3, R2, 1K for the voltage divider. R3 is 1K for the base of the transistor. R4 and 5 are 1K for the communication lines on the XB, and R6 and R7 are the resistors to limit the current on the infrared LEDs, and those are both 120 ohms. So the next part I'm going to solder in is the power switch, and there's the power switch in place. I think I'll add this little dip switch next. That just goes up here. It doesn't matter which way round you put it, so just whichever way you prefer. It's not orientation sensitive. So we'll solder one pin and make sure it's in the right place. Okay, looks good. So solder the pin across from that and check again. It looks to be in the right place, and down flat on the PCB, so solder in all the rest of the pins. I made a small mistake. I put the capacitors in first, but I think it would have made more sense to put the XB headers in. So put the XB headers in next. You just place them there, and if you hadn't put the capacitors in, you should be able to just flip the board over and place it down flat on the surface. But since I have gone and done it backwards, I'm just going to stack up some bits of PCB here and support my header on that. So you should end up with your header sticking through, header pins sticking through here. So what you'll do is solder one pin in place on each and then check that it's right. So that's one pin in place. Take a look, make sure that they are in the right place, that they're flat. So they're both flat, they're in the right place, so now it's just a matter of soldering the rest of the pins in. Starting with the one on the end. Once you have all your header pins in place, your XB header pins, move on to the capacitors. So you can see this line on the back of the capacitor is negative, and also the leg is shorter, so that's the negative leg. So when you look at the holes for the capacitors, you can see this pin is connected to ground because it has these little lines going away from it, and also this one here is connected to ground, so you know that's the negative side of those two. And at the other end of the PCB, you see this one is connected to ground, this one is connected to ground, so you know the ground one is connected to this large ground plane on the back of the PCB. When we hold the PCB the correct way up, we can see that the bottom two capacitors, the ground leg goes to the left, because there's our mark on the left hand side of the capacitor, and up here at the top, the capacitor on the right, the ground leg is facing down, and the capacitor on the left, I'll turn it around, the ground leg is facing up. So those two capacitors kind of face into each other. The best way to know you have it right is to look at the legs. So if the short leg is connected to ground, we can see it in the pad down here, and the positive leg is going way off over here. Again, the short leg connected to the ground plane, you can see it there, and the other leg is connected on the top side, looks like. And then same down here, you can see the short leg connected to the ground plane, short leg connected to the ground plane. So we know that they are all in the right orientation, so we can solder them in place. Okay, that's the four capacitors in place. So the next thing is the transistor that will power the infrared LEDs. You can see the shape of the transistor here. It's on the silk screen, so just widen the legs out a little bit so that you can get it in place. Should look something like that, and then just flip it over and solder it. So after the transistor, the next thing you should do is the header, and there's quite a lot of header. It's all in either 2x4 or 2x8 female header sections. So this is the header for the Arduino. All you do is get your header in position. So that's all the header for the Arduino, and there's one more up the top here, is the socket for the NRF. So once you have it all in position, try and flip it over and solder it in position. And I know right well when I flip this over it's all going to fall to bits, so I'll just do that off camera. Okay, well there's all the header for the Arduino in place. So next thing is the DC jack. It'll be the next tallest thing. So we just stick that in there and just solder that in place. So now that the DC jack is in place, this is a good time to check your voltage regulators are working. So get a DC power supply, plug it in, make sure your switch is over to the left, which is the on position. You can use a contact, a pad here. This is the negative pad for the battery, so you can use that, and then connect your negative to that pad, then this large contact on the top of the regulator is the output. I'm getting 3.31 volts from there, so that first regulator is working perfectly. There's no load on this at the minute, so that's not the most accurate test, but anyway, it'll be okay. The next contact I have 5.02 volts, so the 5 volt regulator is working as well. So far so good. The next thing we need to do is to add the header for the TFT screen. Now, I tried to find some header that was taller than this, but I couldn't find it, and any that was close to what I needed was really expensive. So as a kind of a bit of a bodge kind of solution, I have a stackable header that you get for shields on Arduinos and that kind of thing, so that's pretty common. And these are little jumpers, so normally you'd have 2 header pins, and you'd put your jumper on like that to connect the 2 pins. My little solution to get the header up higher is pretty simple and very cheap. All you do is put a jumper on each side. You end up with your header with 2 jumpers on it, and you get this kind of shape here. So I don't know what you call that, but anyway, that is going to bring up our header so it's tall enough to let the TFT screen stand above the Arduino. So you can see the difference in the height there, and that's just all we need to achieve. So do that for all of the stackable header. I think the best way to do it is to kind of put the jumper upside down, so you can see the jumper has a kind of a little grip piece on the top, and the bottom is just flat. So put the flat side up to the stackable header, so that would hopefully make it a little bit more stable. Now, when you're soldering this, make sure you keep it fixed nice and tightly flat. And if you solder all the pins nice and flat, it won't be perfect, but it'll be pretty stable there. So that'll be a little tricky to do in front of the camera, so again I'm going to do this off camera. So there's all those headers in place. You can see the different heights, and that's a fairly strong solution. I think it'll work. I mean, it's not perfect. I mean, these things are rock solid, but for a thing to stand on so high, it's fairly stable. So I think they'll be alright. So getting close to the end now. The next thing, we'll just stick in the joysticks. I think they're called joystick gimbals actually, these things. Alright, there's the 2 joystick gimbals in place. They're pretty tricky because there's quite a lot of pins you have to get lined up, and some of them move very easily, they bend very easily, like the potentiometer ones, so you could bend them out of shape quite quickly, make things a bit difficult for yourself. The next thing after the joystick gimbals is going to be our encoders. So that should hopefully fit in there. Slag go in something like that, and the same on the other side. You have 3 pins on one side of your encoder that deals with the pulses, and then you have 2 pins on this side which deals with the switch. So where we had the sliding pots before, each pot was 1 action. This can have as many as you like, so you can say adjust the front link servo, push the button, adjust the rear link servo, push the button, adjust something on the trailer, push the button, adjust something else on the trailer. You know, you can just keep adding functions and just cycle through them by pushing the button on the joystick. So you can have, although there's only 1 encoder here, you could have as many controls on this encoder as you want. You just have to keep adding the code. And because we're using a Mega 2560, it's got a huge amount of memory. I have a huge library created for this controller, but I'm still only using about 30% of the memory, I think. So now just solder those in place. So there's the encoders in place, nice and solidly fixed in there. So next thing are these push buttons, and you can see these are pretty long. That is to make sure that they come up through the front cover of the of the controller here. So they're up around about the height of our joysticks. So I just need to put those in position and solder them in, and there's about 20 of those, so it'll take a while. Well, that's pretty much all the parts populated on the board. The only thing missing are the infrared LEDs, which I don't have yet. But if I did have the LEDs, I'll just use this normal LED as an example. I'd be mounting them something like this, so that the infrared was passing out in front of the controller. Now, you notice on the mark in here for the symbol of the infrared LED, there's a flat side on this circle, and you just match that flat side up to your flat side on your LED. So that's the short leg of the LED there. So the next thing to put on is your joystick caps. Now, I find that sometimes if you push these down all the way, they tend to get caught on the frame of the joystick gimbal there. So I think a good thing to do, it could just be the ones that I've got. Maybe if you get, or you know, if you buy different ones, maybe they'll fit better. But I find these ones to be a little bit tight. So I just get a little bit of paper and roll it up into a little ball and push that into the end of the joystick there, just to keep it up a little bit. So just put that into the joystick cap there, and that just keeps it a little bit off the joystick gimbal to make sure that it doesn't hit. What the cap is actually catching on is the top of these potentiometers on the side here. So that's what just happens to catch the edge of the cap a little bit. So you might just want to add a little bit of paper to stand the cap up a little piece off the top of those. Now that that's done, we need to put our brass standoffs on the PCB that will hold the whole thing together. I don't actually have the right lengths for them, they just haven't arrived yet, so as an example I'm going to use these ones, which I think are a little bit too long. So, and well, the top ones are too long and the bottom ones are too short, so I'm wrong on both sides. But when those pieces arrive, I'll update this. But just to give you an idea of what it should look like. So there's the standoffs in place, but before I put the cover on, I'm going to put on the battery holder first. So put it on like this, because the wires are going to be going down here where they get soldered into the PCB. Then we just need to screw it to the PCB. When you have your battery pack screwed into place, you can then cut your wires. Make sure you leave a little bit of room here in case something goes wrong and you have to cut them a little bit shorter. So you leave a little bit of slack, and then you need enough to go through the holes. So maybe cut them down here. The holes are here. The holes are up the top there, and maybe cut them below these two pins. Then just remove the shroud and put the wires through the holes, solder them in place. So there's the two wires for the battery connected in there. Looks pretty good. So next thing we need is the rear covers. So they go like that. Now, like I said, these standoffs are too short, so the proper standoffs will bring the back of the controller up to around about there. Might not be exactly there, but it'll be pretty close. And the idea of these rear covers is to stop the PCB catching in clothes and on your hands, and just to make it feel better in your hands. Like the first version of the PCB felt very small, or well, felt a bit too thin, I suppose, when it was just a single PCB. So that's why I've made these other boards. Hopefully the feel of the controller will be much better. There's the two back panels on the PCB, so let's do the front now. We need to line these all up with the switches to get them to go into place. So should be like that. Well, that feels very good in the hands. It's a much better thickness than the previous model was. So just put those in and screw them in place, same as the rear panel. the last thing now is to put on the caps for the encoders. So when these things come, they might be a little bit rough because they might have still edges here from where they were molded together. I guess they were probably just molded in a long string, something like that, and they just break them apart and to separate them. And also these little kind of guide marks here on the bottom, you might need to file little rough pieces of them away just so that you can get your encoder on. Now your encoder has a switch in it, so you have to leave a little bit of space when you're tightening these so that you can still flick the switch on the encoder. Should be pretty easy to set that up, it's not too complicated. So just give it a tiny little bit of space. Then when you've tightened it, push it down, make sure it's switching, and if it's not switching, then loosen it off and bring it up another little bit. You should hear a good solid click from the switch. So that's really the part that I designed fully assembled there. All the different bits that plug in and out, you've still to add, like the Arduino goes there, the TFT goes here, the NRF24 radio module goes there, an XB goes there if you want to add that. I still have to add the LEDs, but I haven't got those yet. I actually don't have a spare one of these Mega 2560s, so I might have to try and either take that out of one of my original version 1 PCBs, or I'll just have to wait until it arrives, because I have got one ordered especially for this. But this is basically what it is. Everything else you just plug in and you can plug out when you want to use it for something else. So it feels pretty good. The thickness of it feels much better than the other one. The other one was very thin. This feels good and solid in your hand. You can move these encoders now. That's pretty good. They feel alright too. Buttons in the joysticks, buttons in the encoders. All these buttons feel easy to access. Yep, so I'm pretty happy with that. When I've got an Arduino to test this out with, I'll do another video showing you the different functions. I've added quite a few functions to the library for this that I've wrote. I should be able to show you quite a few things with it. There's obviously still a lot of things to add to the code, and I'll be adding to it for a long time, I'd say. But it should be able to get controlling the tractors pretty quickly, and maybe even control something with the XB as well. I do have the Hitachi, still has its XB in it, so I could just add the code for that in there, and we'll see how that works out too. But that's the controller that I designed. I guess it's more like a shield really than anything else. It's kind of like an Arduino shield where you plug in the Arduino, or well, normally you'd plug the shield into the Arduino, but in this case you're plugging the Arduino into the shield. So let me know if you like my design, and if you have any comments or suggestions, let me know below the video or head over to the forum. And I think that's all I have for today, so thanks very much for watching.